So to recap, we want that u or mu of x times p of x equals mu prime of x. Because what that does is we have our differential equation mu of x times dy dx plus mu of x times p of x times y equals mu of x, or on the right hand side, equals mu of x times q of x, right? And so if this is equal to mu prime, right, then our differential equation looks as follows. Mu of x times dy dx plus mu prime times y equals mu of x times q of x. And what you see here is a product rule, right? So we continue that up here. Then we have dx of, and then mu of x times y. And that has to equal mu of x times q of x. And then we would integrate both sides here, get mu times, or mu of x times y, divide by mu, and we can solve for y. So the big question now is, what is that mystery function mu? We know that mu of x times p of x has to equal mu prime of x. And I'm claiming that this is a separable equation, and it may help if I write it as follows. So I'm going to write mu of x, I'm just going to write that as mu, and then I'm going to multiply that by p of x, and then I'm going to write the right hand side as d mu dx. So it may help you to think of the mu as a y for a moment. So I have y here times a function of x and then d mu dx. So I've written, or dy dx, if we think of mu as y. And so we have separated the y's and the x's, and that's a separable equation. So we can use the methods we used from the last section. And the first thing we do is we multiply both sides times dx. And what we get on the left-hand side is mu times p of x and then dx And that equals, on the right hand side, notice that the dx's cancel, so on the right hand side we're left with just d mu. Now in order to integrate, we want all the x's on the left and all the mu's on the right. And we can do that by dividing by mu on both sides of this equation. So what we get then is p of x dx equals, and then we get 1 over mu d mu on the right. Okay, and then our next step is to integrate both sides, right? So we're going to integrate the left-hand side, we're going to integrate the right-hand side. So we cannot do anything with the left because we don't know what p of x is, but we do know what the right-hand side is. The right-hand side, we can write that as ln of the absolute value of mu plus c. So normally when we're solving for mu, we would bring that c to the other side, and that would then give us potentially infinitely many solutions for mu, our mystery function mu. But we only need one mystery function to work. And so the easiest thing here is that we just pick c equals 0. And when we pick c equals to 0, then we can isolate our mu by exponentiating both sides with respect to e. So now I get e to the power, or to the power integral of p of x dx, and then e to the power ln of mu. The e and the ln, they cancel each other out. And so what we're left with then is on the right, e to the antiderivative of p of x dx equals absolute value of mu. So potentially mu could be plus or minus this, and we're just going to pick the positive solution. And so the solution in terms of mu is mu of x equals e to the power integral of p of x dx. So that is our mystery function. It depends on p of x. Now, how do we then find the solution to our differential equation? So what we do here is we take our differential equation in this form, and we integrate both sides. So we have the integral of, and then dx of mu of x times y equals mu of x q of x, and then we have a dx here and a dx here. And then once you integrate, you cancel the derivative. And so on the left, we have mu of x times y equals the integral of mu of x times q of x dx. And we can solve that for y by dividing by mu of x. So that's our final solution here. Y of x equals 1 over mu of x, which is called the integrating factor. So mu of x is an integrating factor. And then the antiderivative of mu of x q of x dx plus a constant of integration, right? I forgot to put that right there. So here's the summary. So this was a lot of theory that you don't have to reproduce on an exam. So here's the summary for the method of solving linear equations. The first step is we want to write the equation in the standard form dy dx plus p of x times y equals q of x. So that just involves dividing by whatever is in front of the dy dx. Then we're going to calculate the integrating factor mu of x by the formula mu of x is e to the power antiderivative of p of x dx. And then I would go straight from there to here. So don't bother with what the book does here. I would just go up here and that is your third step. And that's your whole method for solving linear equations. And we're going to do a bunch of examples in the next few videos.